Alright, hello, this is my COP3503 Exam 2 review video. I've decided to do the topic on maps. So, I will be doing a live demonstration, going over some of the features and syntax. To begin, I'd just like to say that maps are non-contiguous forms of data, where they pair data together, where there's a key and there's a value, and the value is accessed by the key. So I'll just go right into it and demonstrate it. So we have a blank document here. I'm going to start off by including our stream as typical. Then we're also going to include vectors for the demonstration later. And then we're also going to include maps. We need to include maps if we want to use them in our program. Maps can be imported either as just map or unordered maps. You will see later on that maps actually order the data in a particular manner, either in ascending order, by number, or by letter. Whereas a unordered map, which will look like this, just stores the data in the way that it was entered into the map. So we're going to use namespace std, and let's just begin. So the syntax or let's create our main. There we go. Alright, so the syntax for a map is as follows. Map, the first data value, which would be our key. So we're going to use integers, and then the data type of the value that we're going to use, which is a string for this example. And then we're going to give it a name, so we're going to do my map, and that's a map. Now there are two ways of adding data into the map. We could either do my map dot in place, and whenever we do in place, we have to provide in the data for the pairing. So we're going to do 2 as the integer key, and then let's just do 2 as the value that it stores. Right? Or there's a second way of doing it, where we can do my map. We can do the bracket operator. In this case, we'll do 1, and that's equal to 1. So both of these are they're both valid ways of inputting data into a map, creating those pairings. So now, if we were to cout, there's 2 ways of couting. We can do my map dot at, then you provide in the key. So if we do my map dot at 1, and we run this program, we're going to see it outputs 1. And then there's a second way, which is my map using the bracket operator once more, and just like that. So similar to using the bracket operator to create a map, we can also do it to output the value based off the key. So if we run this, now we have 1 and 2. Nice. Alright. Now, let's just create a number of values. Or actually, I think it's best to demonstrate that while using in place, or I guess I rather should say start by saying keys are specific to their value. So you can't have multiple keys going to this to different values, or the same key going to multiple values. So if I were to try to do my map dot in place 1, and then let's replace 1 with 2. Right, and then we try to cout my map dot add 1. We're gonna see that when we run the program, it's gonna stay the same value, so it's not gonna override. However, if we use the bracket operator, you can actually replace the data inside of the map. So if we do my map and now we go to 1 equals, just say something else, and we cout this, my map dot add 1, Now we'll see that it overrid. Alright. So let's just create a more refined example. We'll just go ahead and restart here. And let's create a map of integers and strings once more. And we'll call it a count map. And then let's create a vector of integers called top secret passwords. And let's just give it some random 4-digit numbers. 1, 2, 3, 4, 1, 1, 1. Let's do like 7, 3, 6, 8. Let's do 5 of these. Alright, that looks good. So let's put all of these pairings into our map. So we're gonna create a for loop to put everything in. So in I equals 0. And we're gonna iterate through our vector of passwords. Do top secret password dot size. And increment I. And let's create a temporary string that we'll use as the value for the map. Just call it, let's say, secret password. And then let's do plus toString. So we're going to display the password as the value as well. I know it might seem a little redundant. Or actually, let's do here. Secret password number toString I plus 1. So now we can keep track of the index. And then we'll go like this to actually display the function, or to display the password. toString top secret password I. Alright. So all that this does is it creates a string where it says secret password number. It shows us the number, and then followed by the actual password. So now we're going to place all of these into our map. So we use top secret password I. So that's going to be our key. And then our value is going to be temp. Just like so. There we go. So now we have all of our passwords with a little message inside of our map. Now if we wanted to display everything that was in our map, we can't use a typical for loop. If we just do this, let's do I less than 5, we have 5 numbers, and do I plus plus, or 5 passwords, and we try to see out count map I. You notice that when we run the program, nothing happens. Nothing prints out. That's because we can't actually index through maps. We have to use their key values to access the data. So this doesn't work. But what we can use is something called the iterator. So we're going to create an iterator. And this is the data type for the iterator. So we have to first provide the data container that we want to iterate through. So in this case, we're using a map of integers to strings. The calling operator, iterator, and then give it a name. So we're going to say iter, like that. Okay, now with our iterator, what we can do is we can create a for loop. Let's set the iterator equal to the start of our map. So do count map.begin. And we're going to keep iterating until it reaches the end. So it would be a count map.end. And then it's going to increment as it goes through. Like so. Alright, cool. So now, if we see out, say password. And now it's important to note that iterators, they're not pointers, but they behave like pointers. So if we want to access the data of iterator, we need to use the pointer notation. So pointing to first takes the first of the pairing in the map. So this will access the key, the integer key. And then if we do iter.second, or iter pointing to second, that will retrieve the value, the string value from that pairing. So do that, and then we'll also add message. So this is what the password retrieves. It was just a message stating the password once again. It's a little redundant, but it serves the purpose of this video. So like so now, if we run this, as you can see, we have, it states what the password is, and then it tells us a little message that's displayed by the password. And this goes back earlier to what I was saying about a unordered and a ordered map. Our map, since we're using just the default, just a normal map, it organizes it by alphanumerically by their passwords. But it knows, based off of how we see out of the message, we know that this was actually the first password was put into the map. This was the second, third, fourth, and fifth respectively. However, the map reorganizes it. Alright, so now we can do a little demo showing how maps, I guess, can protect data. So we're going to create a string, and we're going to call it user value. And then we're going to get line. So we're going to have our user type into the command line. We're going to store their value into their user value, and then we're going to convert that to an integer, like so, using stoy. Alright, so now, after the program displays all the passwords, it will prompt the user for input, and we're going to store it in our user value as an integer. So now we're gonna use a new function called find, and this will basically be able to allow us to find the value associated to a pairing based off of the key, if the right key is presented. So we're gonna create another iterator. We're gonna do map, again, integer string. Let's just call this iterator just 2. That's fine. And we're going to set it equal to the count map dot find the user value, like so. So what find does is it searches, based off of the input, it searches for a pairing with that key, and then it will return the iterator value for that pairing. And now actually what we can do is we can replace our data type with auto, because we're setting our iterator equal to something. So since the iterator knows what it's trying to find, it's looking through the count map, it knows this is the data type, we can replace this with auto, so we don't have to be redundant. So now we can just say if our second iterator, so iterator 2, equals to count map.end, this would mean that it would have iterated through the entire list of maps, or draw the pairings in the map, and it wasn't able to find a result, so it just returned the end of it. So if it returns the end of it, then you can say that there was no password, or we could say nothing was found. So we'll say, sorry, the password doesn't match. I suppose that's a better way of saying it. And then else, what we can do is we can actually print out the password that it was able to find. So we'll do similar to what we did before, where iter 2 acts as first in our message. We can probably could have copied that over, that's fine. We'll do the same thing. There we go. So now if we run the program, it's going to prompt the user for input. So let's say we put in a random password COP3503, which is not one of the listed ones. Let's say, sorry, the password doesn't match, and the program ends. And then if we were to type in something that we do know, let's say 7261, it's going to return what the password is, like so. And that's pretty much the basics of maps, going over some syntax and some functionality.